question was, how many? So it was a question with sub-questions, and it said calculate the following energy calculations for the following problems. Okay, and A was how many kilocalories are released. I'm sorry, can you read it again?
It says, calculate the kilocalories for each of the following. It says they're 125 kilojoules.
Okay. From burning 125 kilojoules celery, piece of celery that we know is 125 kilojoules in a calorimeter. Okay. So with energy questions, I always stop and think, are they asking me to do a full-blown heat equation calculation, or are they simply asking me to convert? So in this case, they're simply asking you to convert, okay? So they're not mentioning specific heat. They're not mentioning how many grams the piece of celery weighs. All they're asking you to do is take 125 kilojoules and tell us how many kilocalories that's equal to. So it's just a simple, straightforward conversion. So our given information is 125 kilojoules. Our needed information is the number of kilocalories. So let's do this. We've learned that 1 calorie is equal to how many joules? 4.184. You all have to know this for the test. It will not be given to you, not meaning to scare you or to be preachy or anything like that, but is equal to 1 calorie. This is one of the many conversion factors that you will need to know on your test next Tuesday. Hi, Tony. And if you don't know that, then you're going to miss a 5-point question. So if you got nothing better to do this weekend, go home and make sure you know. I'm going to make you all a list of conversion factors that you need to know for this test at bare minimum. And you're going to leave here with them today, and I'm also going to post them to our page, okay? So this is a basic energy conversion factor you all must know. Okay, so now let's start the equation. Let's draw ourselves a roadmap, okay? So we're given information in kilojoules. Can we go straight from kilojoules to kilocalories? Probably could, because I think we could just put K in front of both of those, but let's not do that. We need to practice. So we're going to go from kilojoules to, what kind of a conversion do we have? We have a joules to calories, okay? Let's say that's the only one we feel confident that we know. We know there's 1 calorie in 4.81 joules. Okay, so we know we've got to go from kilojoules to joules. That's much certain, okay? Now we can use our conversion factor to go from joules to calories, and then our needed information is kilocalories. So now we're going to wind up in kilocalories. Okay, so now that we have a roadmap, we know that we have to have 3 steps. So we're going to have 3 conversion factors. We've got this one down pat. Next, we need to know how many joules are in a kilojoule. Anybody?
How many joules are in a kilojoule?
Yep.
1,000.
So there's 1,000 joules to 1 kilojoule. And remember, anytime you write a conversion factor is nothing but a ratio, okay? So you can write that conversion factor. It can be written in 2 different ways, and it means exactly the same thing. Which one of these 2 that you use depends on how you're trying to maneuver through your equation. Because remember, if you're trying to go from one thing to another, one unit of measurement to another, you'll always have the like units of measurement going diagonally. So if you're in kilojoules and you want to go from kilojoules to joules, kilojoules and kilojoules will always go cross out diagonally, okay? That's why we write that both ways, so you can choose from. Okay, secondly, we're going to need to know, how do we get from calories back to kilocalories? So we need to know how many calories are in a kilocalorie. Anybody?
1,000.
1,000 calories. This kilo is 1,000, right? To 1 kilocalorie, or 1 kilocalorie to 1,000 calories. And just likewise, this conversion factor can be written that way as well. So now we've got all of our conversion factors that we feel we're going to need for this problem. Maybe, maybe not. We'll see when we get there. So now what do? We start the problem. And what do we always start the problem with? The given information. So they're giving you the value of 125 kilojoules. Okay? There's where we start our problem. What do we do next? Look at our roadmap. Where are we going? We're going from kilojoules to joules. So that means this conversion factor is the one we're going to use. So kilojoules are going to go on the top or the bottom? Bottom, because you're trying to get out of kilojoules and into joules. I know this seems redundant or whatever you want to call it. When you put that conversion factor in, make yourself an arrow. That lets you know I've gone from here to here, and you can visually double check that's where I'm at. Okay, so now we need to make the jump from joules to calories. That's going to be this middle conversion factor, okay? So we're in joules, and we need calories. So joules is going to go on the bottom, right? So we're going to use this one. I'm sorry, this one. Joules on the bottom. So 4.184 joules is equal to 1 calorie. Okay, now we've made the next leap from joules to calories. Now all we have to do to finish the problem is to go from calories to kilocalories. That's going to be this conversion factor. We're in calories, so calories needs to be on the bottom. We're going to use that one. 1,000 calories to 1 kilocalorie. Okay, draw your arrow. So you've gone from where you started to where you need to be, and you've done so using 3 conversion factors. Now it's time to do the math. Just simply the math portion of it, okay? So I'm going to let you all get your calculators out. Hello.
No.
And I'm going to grab my calculator so I can follow along and double check. Okay, so we'll multiply everything across the top. 125 times 1,000 times 1 times 1. What do we come up with? 125,000. For the top half. Now multiply everything across the bottom. 4.184 times 1,000, which I can tell you, without using a calculator, is 4,184. Don't worry about putting the joules and the kilojoules or anything on the end of that yet. First, you just do the math. So now you divide 125,000 by 4,184. That gives you a total of 29.876 Okay, we can't really name it yet because we want to make sure that we've done everything properly. So we're going to go back to our problem. We're going to make sure that from top to bottom, everything cancels out like it's supposed to. Kilojoules cancels kilojoules. Joules cancels joules. Calories cancels out calories. And we're left in kilocalories. Okay? Are we done yet? No. Why not?
I haven't seen it.
We haven't put the number in the answer in the proper amount of significant figures. So, this is where students are having a little bit of problem. Which ones do I count, which ones don't I count? So we're going to have a little review on that right now. The given information, it's a measured number. The given information is almost always going to count. The only time it wouldn't count is if the given information was like 5 tablets or 10 days or something like that, something that you know is an exact number. Like you could say there are 1, 2, 3, 4, 5, 6, 7 people in this room right now, and there's no disputing that, okay? Celery has a value of 125 kilojoules. There's a little bit of margin of error to that, right? So we call that a measured number. And measured numbers always count the number of significant, count the sig figs. So how many significant figures in 125? 3. Okay. This next conversion, 1,000 joules to 1 kilojoule. Metric to metric and standard to standard conversions are always considered exact. Okay, we know there's exactly 1,001 kilo of anything, okay? So that's exact. So we do not count the number of significant figures in that one. 1 calorie to 4.184 joules. There's margin for error there, right? Because I bet you there was some more digits out to the right of that when the calculation was done however many hundreds of years ago. So that's going to be a measured number, and we're going to count the number of significant figures. Here's the trick, and there's been some debate about this amongst the professors in the book, and I went for clarification. And when you've got a metric to standard conversion, or from one method of measuring to another, we consider that to be a measured number. There's room for error. But you don't count, you count the significant figures in the portion of the conversion factor that isn't the number 1. So we're not going to count the number 1. Okay? Like 1 pound equals 454 grams. You wouldn't count the one significant figure in the number 1, but you do count the number of significant figures in the other half of the conversion factor. I know that's a little confusing, but it is what it is. Okay, so we're going to count the number of significant figures because this is a measured number, but we're not going to count. Ones don't count, okay? So how many significant figures is that? 4. Okay, so far we've got 3, we've got 4. Now we've got 1 kilocalorie to 1,000 calories. That's an exact measurement, right? So we don't need to count the significant figures in that because it is standard to standard. I know it looks like it's metric because it's got kilo in there, but we're just using the metric prefixes and applying it to a standard term. So anyways, so we do not count the significant figures. So with multiplication, which is all we've done is multiply and divide. Multiplication and division. What's our rule for significant figures?
It has to have the number of the least.
You always take the least number of applicable significant figures and you predicate your answer on the least number of significant figures in your problem. In this case, we got 3 and 4, so 3 is the least. So we have to put 29.876 into 3 significant figures. How do we do that? Yep, I got a trick for this for y'all, okay? I've had some people express problems with figuring out skeleton. Okay, if you got you have to put a number in 3 significant figures. There's a trick I like to use. Start from the left, underline 1, 2, 3. You know you get to keep those 3 numbers. That next number to the right that isn't underlined is going to determine whether this last underlying number is going to stay the same or whether it's going to round up. Okay? So 7, anything between 5 and 9 is going to cause the number to the left of it to go up, right? Okay, so we're going to round up in this case, which makes this a 9. So that's 29.9 kilocalories. Is that what the book comes up with?
Let me check. Let's see. Yes, that's what it has.
29.9 kilocalories. Okay, any questions on any step in that? Now's the time to ask. Instead of thinking, oh, that's a dumb question, I'm just going to figure it out on my own this weekend. Tuesday's your test, so we're all in here to help each other. If you think it's a silly question, go ahead and ask it anyway. I've asked a bunch of dumb questions in my career as a student and in my life. Everybody got it? Good on that?
Mhm.